Hello. So this tutorial will look at making a basic geometry in Blender, and then bringing that geometry into Rhino and more specifically into Grasshopper, just to get an introduction to how the workflow between Blender, Rhino, and Grasshopper is going to work. So let's go ahead and make a plane, and let's give it some dimensions. We'll give it a size of, let's say, 10 meters. And then let's go into edit mode. We will give it a couple of loop cuts, one in each direction. Once we're done that, let's remain in edit mode, and we will select these vertices, the ones in the middle, and let's just raise it up. We'll say, let's go to 7. No reason, but it's kind of nice. So now we have this really basic geometry. So let's go into object mode. We're going to go into modifiers, add a modifier, subdivision surface. And for this experiment, we will remain at 2 levels in the viewport. Let's say keep corners for whatever reason. And let's bring this geometry into Rhino. So let's go into File, Export, FBX, save it wherever you like. So I'm just going to save it in my downloads, selected objects, and just going to name it simple Pavilion. Export FBX. All right, now let's go into Rhino. So first things, make sure your units down here are in meters. So they should remain in meters. Let's go File, Import. I'm going to my Downloads folder. Bring in the simple Pavilion. And open import meshes as sub-D surfaces. Prop scale on import is fine, so press OK. And I'll say yes. All right. Here we have our geometry. Now, remember some of the stuff we looked at in the visualization class. So let's go into display. I don't want this annoying grid showing up in the back, so I will just go into grid and axis settings, press on grid, and we can keep the C-plane axis on. Okay, so now we have this surface. So why don't we begin with some of the basics? So we have this as a sub-D, so let's convert this to NURBS, because that's the geometry we want. I'm not going to delete input geometry, so say no, sub-D options. I'm going to keep faces as packed. So let's see. Pick my surface, move it aside. And then let's get into some of the basics of this NURBS surface here. So if I was to press DIR, this shows me directions. Now, as you can see here, the white is typically your normals. I believe the red, let's see, U reverse. Yeah, so the red is my U direction. And using this, you can reverse the direction, but right now I'm going to keep it as it was. V reverse is the green direction. So again, I will keep it as it was. And this is just to show you kind of how you can look at directions of your U and V's, and then also your normals, so everything is pointing in the right direction. I'm going to leave the U's and V's as is. And let's take this surface now into Grasshopper. So first things, I'm going to turn on my bifocals so you can all see what we're looking at. And let's begin. So the first thing I want to bring in is the surface. So right click on the surface, set one surface. Let's select the surface. And in Rhino, I will select the geometry I brought in. I'm just going to press or type out hide, so it's not in our way. And now we have our surface in Grasshopper. So let's go ahead and trim this surface. So the first thing I want to do is I want to trim the surface in multiple directions. So how do we do that? So there's a command called isotrim. And isotrim will subdivide the surface into pieces based on a domain that I construct. So because we have U and V, so I'm going to type out divide domain, but I will select divide domain square. So divides a two-dimensional domain into equal segments. And this gives us a U count and a V count. So into domain, I will bring in my surface because that's my domain. And then I will give this, let's just use a number slider with 10, U count, and into V count. And let's go ahead and plug this segments into the domain. Let's see what happens. So look at that. So now this has been divided into a 10 by 10 domain, and it's giving me 100 untrimmed surfaces. So that makes sense because it's 10 by 10, U in U and V. Okay, let's go ahead and hide this first surface. So I'm just going to select it and press Control Q to hide it. So now I only see my isotrim. Now, what I want to do is I want to evaluate the surface. So how do we do that? So evaluate surface is a component in Grasshopper. So you bring your surface in, and then it's asking for a point to evaluate the surface on. So I could give it the segments that I've created. Actually, no, it doesn't work that way. Let's go ahead and give it a point. So what I'm going to use in this case is MD slider. So MD slider gives you this a multi-dimensional slider. So it basically works in 2 dimensions. And in this case, it should be giving me the ability to evaluate my surface across its entire sort of domain. But as you can see here, right now, it's not really moving across it. It's kind of just isolated within this one little square over here. So why is that? So let's try to understand the topology of this NURBS surface. So if we hover over domain, you can see how it says here U is 0 to 16 and V is -2 to 14. For whatever reason, this is kind of how it subdivides its numbers. So I could do a couple of things here. One is I could actually right click on my MD slider, or not right click, double click on this little dot on your MD slider, and see how it's asking for some domain information here, X domain and Y domain. So in my case, because we want to see this domain, so I could actually read it off by just hovering over domain, or I could type out domain square. So you could do domain, but in our case, domain square is applicable. I plug my surface into domain square, and let's plug in a panel. So this panel actually now shows us the U and the V. And that's kind of what the same thing is in the domain here. So I can go ahead and double click on this dot here and match this to my U and V. So 0 to 16 and then -2 to 14. Let's press OK. And now you can see if I move my MD slider, it basically allows me to evaluate across the entire surface, not just within a constricted cell, because now I've given it the correct UNV information. So there's something I want to show you here. So you can see at the bottom of the MD slider, this is where the U changes. See how the V starting at -2 remains the same. So that's the U, and then the V is in the Y direction, this way. Y direction meaning the Y direction on the MD slider. So let's have a look at why this is subdivided into 14 units. So as we can see, 0 is the beginning of the first cell, and then as we move up, 1.5 is about here, and then another 3, 4.79. This is sort of how it's divided across the domain. But let's turn on the original surface. So just show in Rhino. And then I'm going to hide everything over here except the evaluate surface. I'm just going to hide everything else. And then let's have a look at the MD surface that goes across. So let's just count a number of cells. So we actually have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. But our U goes from 0 to 16. And you can see it sort of going across here. So it kind of creates its own domain. So let's see, 0 is here. And then as I move along, 1 is about here. This is about 2. This is about 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on and so forth. So it's actually consolidating some of these smaller outside strips together in order to create its own sort of UV domain. So it's not really taking the number of panels that you already see here into account. It's sort of doing its own thing. So this is important to understand because this is how the geometry is actually constructed. So let's go back. We're going to hide this geometry one more time. Let's enable our isotrim. So press it and then type Control Q. And again, we have our MD slider that's working across the entire surface. So this is what we've done now. And now we have a 10 by 10 domain. So the next thing that we're going to do is we're going to look at sort of how the points are working together. So in order to do that, let's first create a line. So we will create a line between the points on the surface. And then what I want to do is take the points from evaluate surface. So as this point moves along, so this is basically giving me the point that's up here. And then I want to create a line between all of the existing surfaces. So in order to do that, I have to get the centroid of each cell in this NURBS. So let's go into area. So when I take the area of the geometry, see how it's giving me the centroids of each of these cells or each of the subdivided surfaces. So I will enter the centroid in the endpoint. So now, if I was to move the MD slider around, you can see how it's actually constructing a line between the evaluate surface as it moves along, and then the centroid of each of these subdivided surfaces. So the next thing what I want to do is I have a line, but I also want to measure the distance of that line. So there's two ways of doing this. You could actually um, go into the length of the curve, and this will give you a panel with all of the different lengths. And then the other way is sort of taking one step back uh, and just using the distance component and then plugging in point A and point B. So in our case, for this one, we're going to use this distance component. You could also use the other one, but this is the one that I've tested already. So this is what we'll use here. So now this gives you a list of distances. So now let's say if I want to visualize these lines, I want to give it a bit more of an interesting visualization. We're going to do the same gradient that we saw in our visualization class. So let's just pick something interesting. My distance will go into bounds because I want my lower and upper bounds. The domain of this will go into upper limit. And then my distance will go into parameter because that's what I'm measuring. And then let's bring in a custom preview. I'm going to put this into material. And then my geometry, actually, instead of custom preview, let's use custom preview line weights. So geometry goes, line goes into geometry, gradient goes into shader, and then let's bring in some thickness. We're going to go 0, 0.005, 1. Let's see what this does for us. And then for absolute, I'm going to go set Boolean true. Okay, so now you can see I have a bit more of an interesting line situation going on here. And then as you move your MD slider, the colors will change because of how it's picking up the colors from the gradient. And then this is somewhat of how attractors also work. So you can consider this as sort of like an introduction, very tiny introduction to attractors. But this is one way to visualize the distances. Okay, so let's put this aside. This isn't important right now. What we will do is we're going to move on. I'll just put this into a bit of a group, make it a blob, and then let's turn them off. So Control Q will turn off preview. Okay, so what I want to do now is I actually want to visualize my actual cells based on how I move around my MD slider. So what I'm going to do here is let's actually copy over this gradient. And I am going to remap numbers, bring in a distance, bring in the source. Now it's giving me these mapped numbers here. And then into the map numbers, I will take in, I'm going to take my map numbers into parameter and then remove my upper limit. Let's see what this gives us. This is another way of using gradients. Okay, let's see, there might be something I need to do over here. Well, this isn't very good. Geometry does not go in here. Gradient goes into material. And yeah, actually, we'll come back to what I did here. So the gradient will go into this, and then I will bring in my isotrim surfaces into geometry. So now we can see as I move my MD slider around, you can see how your colors change. And this is just because I've built a parametric relationship. So I did something here, and I'm just going to backtrack to what it was before. I'm going to remove reparameterize, and I will enter the values in here. So 0 to 16, and then -2 to 14. Let's see if this makes a difference again. So I'm back to my original settings. Yeah, so this works. Now, there's something I did here, and I'm going to show you exactly what that was. So if I was to go into my surface and select reparameterize, you will see that my U value actually changes from 0 to 1, and my V value also changes from 0 to 1. Right now, my MD slider is not working because I need to reset the values on this as well. So to match this U and V, I'm going to double click again on the dot on my MD slider. So 0 to 1, and then 0 to 1, because that's what's shown here. So what reparameterize does is it resets the surface from having sort of its own domain to being reset to a 0 to 1 domain. So everything becomes 0 to 1. So divide domain gets the 0 to 1 U's and the V's, but I'm still dividing it. So the isotrim still operates the same way that I intend for it to operate, 0 to 1. And then the MD slider matches my U and V count coming out of the geometry. And by default, I'm able to just use 0 to 1, 0 to 1. And that's what I that's what I enter into the surface for evaluate surface, and therefore it works. And what I did here, this is also interesting to understand. This is another way of using gradients, is I took my bounds and I put my bounds into the source for remap numbers. And what remap numbers does is it remaps the numbers into a new numeric domain. So my source is my bounds, which is my start to finish, which is 0.479 to 8.25, which is the lowest and the largest distance that I have available. My value that's being value to remap is the distances within this source that's coming out. And then if I was to hover over the mapped values, that's actually, we can look at it in the panel here, that's actually now mapped between 0 to 1. There's nothing greater than 1 in this entire thing. And you can see the first value is 1, which is probably the largest number in here. And then because on my gradient, the lower limit is 0 and the upper limit is by default 1, when I put my parameter in here, based on these mapped values, because that's also from 0 to 1, the gradient works without needing any other information. So as I move my MD slider around, now my gradient is working. So that's an introduction of bringing NURBS geometries in from Blender to Rhino to Grasshopper. The other thing we can do in here, and this is just for fun, is we can actually look at our point list. So let's add a point to each of these centroids.